FM. In today's lesson, we're going to focus on the trigonometry of acute angles. Today's lesson is made up of two parts, trigonometric ratios and right triangles. And these two aspects are so important in helping us define the different trigonometric ratios and bringing them together. So I have a nice little acronym, SOH CAH TOA, that helps us define the different trigonometric ratios. So SOH is the sine of any angle is equals to the opposite side of the angle divided by the hypotenuse. CAH, the cosine of the angle, is equals to the adjacent side to the angle divided by the hypotenuse, and TOA, the tangent or the tan in short of any angle, is the opposite side of the angle to the adjacent side. And to get a pictorial view or picture of the different trigonometric ratios, we need to apply this to a right triangle. So here I have a little schematic that I've drawn, and this schematic or this diagram is going to help us define the different trigonometric ratios. Example, if 5 tan theta is equals to 12 and theta lies between 0 and 90 degrees, use the sketch to help you find the values: sine theta, cos theta, the sum of sine theta and cos theta, and tan squared theta. So we're going to use this information given and map all this information to the schematic drawn. So this is information is sort of like an algebraic view of the information, and the picture or the diagram gives you more of a pictorial view of the information. So we can use the information given, that is 5 tan theta is equals to 12, and we can plot or map this information onto the right triangle. So 5 tan theta can be written as tan theta is equals to 12 over 5. And by definition, tan theta is the opposite side divided by the adjacent side. So let's define our angle on the right triangle. That is theta. And remember, the angle always runs counterclockwise from 0 degrees. So theta is the opposite side, and the side opposite to theta here is this side, is equals to 12, and the adjacent side is equals to 5. And by inspection we can see this is a right triangle, so it's possible to find the hypotenuse because we need it for the other trigonometric ratios. And to find the hypotenuse for a right triangle, we use Pythagoras theorem. That is, the hypotenuse squared is equals to the sum of the squares of the other two sides, opposite squared plus adjacent squared. So the opposite squared is 12 squared plus the adjacent is 5 units, so that's 5 squared, 144 plus 25, and 144 plus 25 is 169. So therefore h should be equals to the square root of 169 plus minus. This implies that h should be equals to positive 13 units because distance is only in positive units. So now we have all the information needed to define the other trigonometric ratios. So that is why getting a pictorial view of the information given is so important as to help us define the other trigonometric ratios. So according to the acronym, sine theta is equals to opposite over hypotenuse, and that is equals to, the opposite side is 12 over 13. The hypotenuse is 13. The cosine of the angle theta is the adjacent side by definition, CAH. Adjacent side over the hypotenuse, and the adjacent side in this case is 5 and the hypotenuse is 13. So now it's possible to find the sum of the two ratios, trigonometric ratios. So sine theta is 12 over 13 plus the cosine of the angle is 5 over 13. So 12 thirteenths plus 5 thirteenths is 17 thirteenths. And lastly, the tangent squared of the angle theta. So before we look at this question, we must understand that by definition, tan squared of theta is identical to tan theta the whole squared. They're exactly the same. So let's apply that. So tan squared theta is equals to tan theta the whole squared, and tan theta is given, or we can look at the diagram as 12 over 5 the whole squared. This is the same as 12 squared over 5 squared, 144 over 25. Thanks for watching.